10.1 Ellipses. So in the past, you've probably talked about circles. Right? This is a circle. It's perfectly round. Ellipses are very close to circles. They're more what you think of when you think of ovals. So they're like wide or they're tall. They're elongated circles. Ellipses are part of a group of curves. When I say curve, I mean graph. Curve is the mathematical word for it. Let me just label that these are both ellipses right here. So ellipses are a type of curve that are obtained from taking cross sections of a cone. So ellipses fall under this family of curves known as conic sections. So we're going to talk first about conic sections. So a conic section is going to be a graph obtained by taking a slice of a double cone. I'm going to use the word cone instead of double cone, but a cone would be this. This is a traditional cone. This is not the type of cone we're going to be talking about. A double cone is the cone that the term conic sections comes from. So a double cone extends out in both directions. It goes down infinitely. This is a 3D graph, so you have like a y-axis, an x-axis, and then a z-axis. You don't need to worry too much about this. I'm just giving you background information. Don't get too overwhelmed. But if you could imagine taking a piece of paper and then somehow just kind of sliding it in to cut through this double cone, you can imagine everywhere where this cone cuts through the paper forming an image. So there's 4 different types of conic sections. The first is a parabola. So if you can imagine this piece of paper, it won't intersect this top part of the cone, it just kind of intersects this bottom part of the cone, and this yellow line right here is the shape of a parabola. A circle happens when you put the paper just flat through and you just get a perfectly round circle. An ellipse, which we're talking about today, is the conic section where you tilt it a little. Now, notice with this guy down here, this piece of paper won't come back out through the side because it's lying perfectly parallel to the cone, whereas this ellipse is going to come back out through the side and give that nice ovally type shape. And the third type of conic section is a hyperbola, from putting the paper up and down, so you get a little bit of a cut there and a little bit of a cut there. So knowing that these different graphs come from a cone isn't the most important thing, but I think it is interesting to understand why we're going to talk about ellipses and hyperbolas and circles and parabolas all together. So I won't bore you anymore with this cone talk. Let's go back to thinking about circles, because circles are kind of the predecessor to ellipses. They are the most simple version of what an ellipse is. If you remember back in Math 126, the formula for a circle in the plane is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, the center is the point h comma k, so here's h comma k, and r represents the radius of the circle. So just kind of keep in mind this formula of a circle. Ooh, didn't mean to do that. Keep in mind this formula of a circle as we go into talking about ellipses. Now, this graphic right here is part of a PDF that I've posted on Canvas that you should very much print and keep with you as you're doing your homework and as you're doing exams. I highly suggest having this printed. You're going to want it. But now let's kind of talk about what's going on here. There's 2 different formulas for an ellipse, and this has to do with whether the ellipse is wide or if it's tall. So before we talk about all of this stuff, why don't we talk about these pictures down here and what they represent? The first thing to talk about is the major axis, and you're going to see some major and minor axis talk down here, but the major and minor axes have to do whether the ellipse is more wide or more tall. The major axis is the axis in which it is biggest on. So for this guy here, the major axis is x because it is more wide than it is tall. And you see right up here, it has the major axis listed as x. The major axis on this ellipse is the y-axis because it is more tall than it is wide. From there, let's talk about all of these little dots that are in here. So the first thing, maybe the easiest thing to start with, is this guy right here, which is the center. Right. The center is at the point h comma k, which is what it says right down here. The center is just the very center of the ellipse. Nothing really special happening there. That's the center. On the major axis, these last two endpoints, we call those the vertices. Individually, each one is a vertex. Together, they are vertices. So these guys right here are the vertices of this ellipse, or singular is vertex. Because the major axis is the y-axis in this ellipse, the vertices are going to be here and here. So the vertices belong on the endpoints of the major axis. On the minor axis, so for this guy, the minor axis is the y-axis. For this one over here, the minor axis is the x-axis. Those endpoints are called co-vertices. So this is a co-vertex, and this is a co-vertex. And then over here, this is a co-vertex. And this is a co-vertex. Now let's talk about these little pink points right here, 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 and here. You'll notice that these points, they lie on the major axis. So the major axis here is the x-axis, the major axis here is the y-axis, and these points are called the foci. So that's this word here. It looks like it's foci, but it's foci, and individually each one of these is called a focus. So these are the two focuses, foci, but this is a focus, this is a focus. Together they are the foci of the ellipse. And the idea of foci is a little bit weird, and I don't anticipate you 100% grasping what I'm about to say or why anyone would care. But let me just give you a little bit of reasoning for what the foci of an ellipse are. So looking at an ellipse, if we have any point on the ellipse, the foci are plotted such that the distance between the focus and this point here and the focus and the same point, when you add these two together, you get a constant no matter what, which ends up being the length of the major axis. So this distance plus this distance end up always giving you this distance here. Okay. Just to give you a little bit of reasoning behind this. So let me go ahead and label these. This is a focus. This is a focus. Focus and focus. Now let's look back at these formulas up here. You'll notice that we have a statement. The very first one is A is greater than B is greater than 0. So this is saying that A and B are positive, and also saying that A is always the bigger number. What I want you to notice here is that the major axis on this ellipse was the x-axis. A is always the bigger number, and A is underneath this x term here. So if we look at the other picture, major axis is the y-axis, and A is underneath the y. So the variable with the bigger number underneath it, and A squared will be bigger than B squared, so just ignoring the squared parts, whichever of these has the bigger number underneath it, x or y, that's going to tell you what your major axis is. So why don't I make a few notes over here. So the variable with the bigger number under it is the major axis. Another thing that I want to note is that the foci and the vertices are always on the major axis. So notice here, foci, vertices on the major axis, same thing over here. So I'll write that down as well. Finally, I want to talk about A, B, and C. These are going to be the letters you see in this picture and that are also being used up here. H, K is the center, just like it was with the circle, so I won't bother talking about H, K. C, really quickly, is the same thing as the square root of A squared minus B squared. The formula here has it, let me just make that a little better, squared minus B squared. So the formula has it written as C squared equals A squared minus B squared, but since C has to be a positive value, it's easier to just kind of solve for C there. So I'm just going to leave that there. All right, so down to our pictures. You're going to notice that A is the distance between the center and the vertex in both pictures, right? This distance right here is A. That's a terrible A. That would mean over here, same idea. I can't make a beautiful curly bracket, but that would be A as well. This right here is A, and this down here, this distance would be A. The distance between the center and the co-vertex is the distance B. So this distance right here is also B. The minor axis is the x-axis in this picture. So this distance between the center and the co-vertex is B. If I can draw curly brackets to save my life. All right. And then finally, the distance between the center and the foci, that's going to be the distance C. Because this distance here, so this is the entire major axis, this distance here is A, this distance here is A, the length of the major axis is 2A, and it's going to be the same thing over here. This is A, the length of this entire major axis is 2A. And for the same reason, the length of our minor axis is going to be 2B. Right. So A is going to be coming from whichever your major axis is. It'll be the square root of whatever number is underneath your major axis. B is the square root of whatever number is under your minor axis, and then C is going to be the square root of A squared minus B squared, and that's the different distance from the center to one of the foci. Now, it's going to be a lot easier if we just start using this to do problems. So that's what we're going to do. Now, as a note, I do have all of these problems that we're going to do today in the form of a PDF file, so you can print off this PDF file and follow along, and I would suggest doing that. For these problems, for the first few, what we're going to be doing is finding A, B, C, the center, the vertices, the foci, the length of the major axis, the length of the minor axis, and then we're also going to be drawing the ellipse itself. To begin with, we need to figure out where the center is. That tends to be the easiest part. So you're looking at, up here in our formula, H and K, if I go back to my formula page, H and K in both scenarios are the coordinate points for the center. And it's the opposite of what it looks like because there's a minus sign there. So if this is a +3, that means that the x-coordinate of the center is going to be -3. The y-coordinate of the center is the opposite of -2, so it would be +2. So the center is going to be at -3, 2, which is going to be right about there. Next, we're going to go ahead and pick this apart right here. remembering that the bigger number is underneath the major axis. And additionally, the bigger number is always A. The bigger number is always A. So if I look at the formula we have, x plus 3 quantity squared over 9 plus y minus 2 squared over 25 equal to 1, well, clearly the bigger number is 25. So that would mean that a squared is equal to 25. Taking the square root on both sides, we get a is equal to 5. Here, b squared, because it's the smaller number, right? The smaller number is 9, the bigger number is 25. So smaller number is b squared. So b squared is equal to 9, which means b is equal to 3. So I have 5, 3, and then to find c, we need to use a and b together. So c is equal to the square root of a squared minus b squared. So a squared was 25, b squared was 9. That means that c is the square root of 16, which is going to be 4. I don't like the way that 4 looks. Better. So we have a, b, and c at this point. Now, because the bigger number was underneath y, we know that y is the major axis. So I don't have a place for that. That's also not how you spell major. Major axis. We probably should have a place for that. Y is the major axis here, which means that we are going to be looking at tall and skinny as opposed to short and wide. And that also means that the a value is telling us that we need to go up and down from there to figure out where to plot our vertices, because the y is the major axis. So we're taking this a value and we're going to go up 5 units and down 5 units, and those points that we plot are going to be our vertices. So let's see. 1, 2, 3, 4, 5. That would be right here. Going down 5, there's 2, 3, 4, 5. Right. This distance right here is A, which is 5. So this right here is a vertex. Down here, this is a vertex. Our co-vertices are going to go on the minor axis, which is going to be the x-axis, and they will be 3 units away from the center. So this is the center, and we're going 3 units away, so left and right, 1, 2, 3. This is a co-vertex. 3 on the other side, that's our other co-vertex. And we can now fill in down here. So we have the vertices. This is the point -3, 7. And the other point down here is the point -3, -3. And this distance right here, I'm just going to label that this is b equals 3. We have enough information at this point to draw a ellipse in there, so you're about to learn that I am not an artist. Here's my ellipse that's drawn. I am going to plot the foci on this as well. So C tells us how far from the center our foci are, and again, they are going to be on the major axis, and y is the major axis. So counting 4 units away from the center, 1, 2, 3, 4, this is going to be a focus. And the same thing right down here. This is the focus. So if I just kind of label this C is equal to 4. That's the distance from the center to each of the foci. I now have those locations, so I can list these points down here. So we have -3, 6 for one of them, and the other one is at -3, -2. There are formulas on this sheet over here for finding these, but I think that it makes a lot more intuitive sense if you just kind of do it manually. You'll have a lot better luck that way. Anyway, the length of our major axis, that's always going to be 2a, and the length of the minor axis will be 2b. So 2 times 5 is 10. That's the length of our major axis. And 2b, that's 2 times 3. 6 is the length of our minor axis. And there we go. We've plotted the ellipse. We have found everything we need to know about the ellipse. So I'm going to pause it real quick and write a few recap things right here and push play. Hold on. All right, so just quick recap. The vertices, since y was the major axis, the vertices are going to be a equals 5 units up and down from the center. So this whole distance here is a equals 5. Same thing from here to here. For the foci, those are 4 units up or down from the center. Also, because y is the major axis, let me end that parenthesis. Oops, there we go. So the foci are also on the major axis, which is y. And then the co-vertices, because the minor axis is x, the co-vertices are plotted b equals 3 units left or right of the center. So those are how I got to plot all my points, and then I just did my best to draw an ellipse around it. And there you go. Let's do another problem. All right, so here we have x plus 1 squared over 36 plus y squared over 4 is equal to 1. To get the center, we are looking up at this top part here. The x coordinate of the center is going to be -1. But this guy right here doesn't have any number next to it. Technically, it's y minus 0 squared. So the y coordinate of the center is at 0. So the center is at -1, 0, which is going to be right here. This will be my center. Now let's take this equation and write it over here so we can mess around with it a little bit more. Remembering that the bigger number is going to be a, so 36 is bigger, so that means a squared is 36, and a would be 6. This would make b squared 4, means b would be 2. Because the bigger number was underneath the x, we can say that the x-axis is the major axis. Bigger number so that means we are looking at a wider ellipse. Let's find c. So c is going to be equal to the square root of a squared minus b squared. So 36 minus 4. This is the square root of 32. That's not going to be a very nice number, so we're not actually going to plot those foci, but because the foci use c, but we can at least find c. It's just not a nice number. We'll use the formula for plotting the foci. All right, so x is the major axis. A tells us the distance between the center and the vertices. So our vertices are going to go left and right from the center, 6 units. So 1, 2, 3, 4, 5, 6. This right here is going to be a vertex. And then 6 units in the other direction. Here's your second vertex. B tells you how many units from the center your co-vertices are. So I'm going on the minor axis, which is the y-axis. I'm going up 2 units, so 1, 2. And then down 2 units. And these are my co-vertices. I now have enough to draw the ellipse. Oh, I was going to use purple. I'm not an artist. I just do the best I can. Beautiful, there's my ellipse. The vertices are going to be at -7, 0 and 5, 0. I'm just reading them off the graph because there's a point there and a point there. The major axis is always 2a, and the minor axis will always be 2b. That's the length of the entire axis. So this is 2 times 6, which is 12, and then 2 times 2, which is 4. Finally, for the foci, because this isn't going to be nice, counting square root of 32 units this way to plot our foci isn't going to be very nice. What we can do is use the formula from this page here. So we have our wider looking one. So h plus c comma k, h minus c comma k. And you can kind of see where that comes from. So the h value is going to be the x value of each of the points. The k value is the y value. Now, notice in that formula one more time, let's go back a page. The k value stays the same because they're still at the same y level. Their y coordinate won't change, it's just their x coordinate that's changing. So this one would be -1 minus square root of 32, 0, and -1 plus square root of 32, 0. And that's that. Let's do another. So sometimes we're given equations that don't look like they're in the form that we need them to be in. If we look back at our formula page has it so there's always a 1 on the other side, on the right-hand side. This is a 100 there. So what we're going to do is we'll start by rewriting it here. Plus 4y squared equals 100. Our goal is to make this into a 1. In order to do that, I would need to divide it by 100, but I can't just do that to one side. I would have to do it to both sides. Now, I can simplify 25 over 100, and I can simplify 4 over 100, and 100 over 100 is 1. So simplifying, we're going to get x squared over 4, and that's because 25 goes into 100 4 times. So you would divide the top and bottom by 25. Plus y squared over, and then dividing 100 by 4, that's going to be 25, is equal to 1. Now it's in the form we need it to be in. Because there's no x plus something, or x minus something, or y plus something, or y minus something, that means our center is actually just going to be at 0, 0, which is the origin. A squared is the bigger number, so a squared is 25, which means a is 5. B squared would then be 4, so b is 2. So 5, 2. C is equal to the square root of a squared minus b squared. So a squared was 25, b squared was 4. C is equal to the square root of 21, which is not a nice value. All right, we're good now to start plotting stuff. So the bigger number's under y, which means the major axis is the y-axis. Which means it's going to be an up and down, a taller ellipse rather. A tells us the distance between the center and each of the vertices. Because it's the y-axis that's the major axis, we'll be going up and down. So A is 5, so we'll be going up 5 units, down 5 units, vertex, vertex, this is the center. Excellent. The co-vertices are going to be going left and right on the minor axis, so 2 units to the left, 2 units to the right. These are my co-vertices. I have enough information now that I can hopefully draw it better than that. You know, you do your best, but there's an ellipse. The vertices are at, let's see, 0, 5 and 0, -5. The major axis, the length of it will always be 2a, so 2 times 5 is 10. Minor axis, the length will always be 2b, so 2 times 2, which is 4. The foci are going to belong on this major axis here. So from the center, which is 0, 0, you go up square root 21 units and down square root 21 units. You're going to get 0, square root of 21 and 0, negative square root of 21. Again, I'm not plotting those, but because they're not nice numbers, but they would be on this major axis. And that's that. All right, so let's do something a little bit more challenging. We want to find an equation of the ellipse having a major axis length of 12 and foci at 5, 7 and 5, -3. This is really going to be a unwinding of the material that we have. So we do have 2 points that we can plot, and we have this information about the major axis. Let's start with the first piece, which is the major axis. So we're told that the major axis has a length of 12. But we also know that the major axis length is represented as 2a, because 2a, looking back at our formula sheet, way back here, 2a is the length of the major axis. So 2a is equal to 12. Dividing both sides by 2, we'll get a equal to 6. That's useful information. So we now have a equals 6. Let's plot these foci. So we have 1 at 5, 7, so over 5 up 7. Here's going to be one of the foci. I'll just call it f sub 1. And 5, -3, this would be the other, that would be the other focus. We know that the foci are always on the major axis. And because they are up and down from one another, that would mean that the y-axis is the major axis. So that tells me some information. Y is the major axis. We know what A is. Our formula, x minus h quantity squared over either a squared or b squared. Why don't I just write a squared / b squared for a second? Plus y minus k quantity squared over a squared / b squared is equal to 1. So we now know the y is the major axis, which means that the number underneath y should be a. Technically, it should be a squared. So a squared should go underneath y, and then the b squared will go underneath x. So why don't I start filling it out? We still don't know what's going to be happening with h or with k. But we do know a squared, which is 6 squared, should go underneath the y value because the bigger number goes under the major axis. So looking at what's left now, we have h, k, and b squared to find, and then we have our entire equation. we know that the center has to be smack dab between the two foci. So if I count this entire distance right here, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this entire distance right here is 10. That means halfway would be 5 units, right? So see 1, 2, 3, 4, 5. Halfway would be 5 units, which means that the foci should be 5 units away from the center. This is the exact center. So this is the point 5, comma 2, which gives us h and k. So h is going to be 5, and k is going to be 2. I can fill that in over here, so h is 5 minus k is 2. And now all we have left is figuring out what b squared is. So let's think about what we have here. I have a, I have h and k, I know where the foci are, and I also know the distance between the center and the foci. Back in our picture here, the distance between the center and the foci, that's the distance c. So we actually know what c is. So this 5 has to be c. Furthermore, we have a formula. We know c squared is equal to a squared minus b squared. If I want to solve for b squared here, I could add him to both sides. So I get c squared plus b squared is equal to a squared. And then to get b squared by itself, I can subtract c squared on both sides. So b squared is equal to a squared minus c squared. A squared, a is 6, so a squared would be 36. C is 5, so c squared would be 25. B squared is equal to 36 minus 25, which is going to give me 11. Now, you don't need to figure out what b is. Finding b squared is fine because what goes underneath here is just b squared. So I can just flat out put 11 underneath here. So my final formula ends up being x minus 5 quantity squared over 11 plus y minus 2 quantity squared over 6 squared is 36 is equal to 1. So you just kind of have to go with what you're given and unravel it all, and it will all come together. I'm not actually going to draw the picture of the ellipse. It's enough for me in this problem to just find that equation. So let's look at another problem. Find the foci of the ellipse, and we have 25x squared plus 16y squared plus 64y minus 336 is equal to 0. This doesn't look like any of the other ellipses that we've seen, and that's because it's in what we call general form. And it makes it very hard to even tell that we're looking at the equation of an ellipse. In order to deal with this, we're going to need to review a concept called completing the square. So, completing the square, our goal is to get one of the sides down to something that looks like this. This is kind of the big goal here, is to have an x plus or minus a number squared. So the way that we achieve that, the first step, you want to take whatever constant you have and add it to the other side. So here I'm going to add 8 to both sides. I now have 2x squared plus 12x is equal to 8. Now, with what's left on your left-hand side, you should have just x's here. You want to factor out whatever this leading coefficient is. So in our case, there's a leading coefficient of 2, so I'm going to factor the 2 out. If I factor the 2 out, I get x squared plus 6x is equal to 8. Now is the completing the square part. What you're going to do, on the inside here, we're going to be adding b divided by 2 squared. And by b, I mean this value right here. So remember that quadratics are in the form ax squared plus bx plus c. So when I'm saying b divided by 2 squared, I'm talking about taking this value, divide it in half and square it, and you're going to add it in on the inside there. So here we have 2x squared plus 6x. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 here. Now I can't just stop right here and call that good, because I've now introduced a 9 here, which imbalances my equation. In order to bring balance to my equation again, I would need to add the same amount that I added on the left side to the right side, which you might be tempted to say, oh, well, then we'll just do plus 9 here. But that's not quite right either, because we didn't just add 9, we added 9 times 2. So you would want to take whatever number's out here and multiply it by the 9, because you added 2 times 9 to this side. So you need to add 9 times 2 to this side as well. All right. So let me just rewrite. We have 2x squared, x squared plus 6x plus 9 is equal to 18 plus 8, which is 26. Now, this part that's left over can be factored, and it factors into x plus 3 quantity squared. And we've completed the square. Noting that this number right here is half of whatever this number is. And you could FOIL this out if you wanted to verify that it gets us all the way back to here. So that's a quick review of completing the square. Now let's go back to this problem. It doesn't look like we're going to need to complete the square with x, because there's only an x squared term there. But because there's a y squared and a y, we're going to have to complete the square with y. So why don't I write down everything we have here. I'm going to start by adding that constant on both sides. So adding 336 on both sides. I now have 25x squared plus 16y squared plus 64y is equal to 336. I'm going to be focusing in on just this piece right here. I'm going to be pulling this 16, because that's technically the leading coefficient of the y terms. I'm going to pull that 16 out. So 25x squared plus 16, and I'm pulling it out of both of these. So I'll have a y squared, and then 64 divided by 16 is 4. So this is y squared plus 4y is equal to 336. So 25x squared plus 16y squared plus 4y. We're now taking this number, 4 divided by 2, so we divide it in half and we square it, which ends up being 4. And we add it in here, right? We have to add it here. And we also add it on the other side, but we have to remember to multiply by this 16, because we also have the 16 out here that gets multiplied with this 4. So 4 times 16. So 25x squared plus 16. This can now be factored into y plus 2 quantity squared is equal to, hold on, let me grab a calculator. Just kidding, I don't need a calculator. This will be 64 plus 336 should be 400. Now, just like we did in that previous problem, let's see, where is it? In this problem right here, where we didn't have a 1 over here, so we divided by 100. We're going to do that same thing, but instead of dividing by 100, we'll divide by 400 to make this into a 1. So dividing both sides by 400. This will simplify down to x squared over, let's see, 16 plus y plus 2 quantity squared over 25. And that's just simplifying 16 over 400. So 16 goes into 425 times, 25 goes into 416 times, is equal to 1. We now have the equation, right? This is just for us to get this equation right down here. We need to still find the foci. What I do know is that the number underneath y is the bigger number. So a squared is 25, a is 5, b squared is 16, which means b is 4. The number underneath y is bigger, so we can say y is the major axis. We know that the center has an x-coordinate of 0 and a y-coordinate of -2. So the center is at 0, -2. So why don't we go ahead and plot that? Because it's the y-axis that's the major axis, the foci are going to be up and down from the center, and they'll be up and down c units from the center. So c squared is equal to, or let's just do c. c is equal to the square root of a squared minus b squared. So the square root of 25 minus 16, that's the square root of 9, which is 3. So 3 units up from the center, that'll be one of our foci, so this is a focus. And 3 units down from the center will be our other focus. So this one's at the point 0, 1, this is at the point 0, -5. So the 2 foci, which is what we were looking for, are at 0, 1, and 0, -5, and that's that. That's the problem. So again, first step, complete the square. You might have to do it on both, but this time we only had to do it with y. Get it into its ellipse formation. From there, we were able to find A, B, and thus C. We could also find the center based on this equation. Once we have the center and we have C, we just need to figure out where the major axis is. Major axis was the y-axis, which means up and down from the center. And we found our foci and we're good to go. So let's go ahead and just do 2 more problems. Here, find an equation of the ellipse that has center 5, -1, and a minor axis length of 2, and a vertex at 5, 7. There's a lot to break down here. I think we should start with the center. So there's a center at 5, -1. Why don't we go ahead and plot that? So over 5, down 1. This is our center. There's a minor axis of length 2. So the minor axis has length 2b. If 2b is equal to 2, that means that b is equal to 1. And then finally, we know that there is a vertex at 5, 7. So over 5 up 7 puts us right here. This gives us a bunch of information, believe it or not. We're trying to figure out, so it should be x minus something quantity squared, a squared over b squared. We're not sure if it's a squared or b squared at this point. So our equation needs to look like this. Now, the center was given to us, so this would be -5, and then this would be +1. Now it's time for a squared and b squared. We do have b, we just need to know where it goes. Because the vertex is up from the center, that means that the y-axis is the major axis. So y is the major axis, which means the bigger number needs to go underneath y. So a squared goes underneath y, and b squared goes underneath x. We know that b is 1, so b squared is also 1. So this would be 1 underneath here. Now to find a. We know that a is the distance between the center and the vertex. So this distance right here has to be a. If we count 1, 2, 3, 4, 5, 6, 7, 8. The vertex is 8 units away from the center, so that means that a is equal to 8. So a squared, that's 8 squared, which is 64. So our final equation is x minus 5 squared over 1 squared plus y plus 1 quantity squared over 64 equals 1. Now, I guess I really don't need to have, that square there. This is unnecessary to write like this, so if you wanted to make this a little more compact, you would just write it as x minus 5 quantity squared plus y plus 1 quantity squared over 64 is equal to 1. But both of those equations are correct. So really, with these problems, just break down what you have and then think about what A, B, and C mean, and remember that you have a formula that relate them together. We didn't have to use it in this problem, but we've had to use it before. So using the fact that c squared is equal to a squared minus b squared can come in really handy. So let's just do one more problem with the, the equation in standard or in general form. And let's do some completing the square. So I'm going to rewrite this over here, but I'm going to group the x terms together. So these guys are the x terms, and I'll group the y terms together as well. And at the same time, I'm going to already have moved this 376 over. So we have 25x squared plus 200x plus y squared minus 2y is equal to negative 376. I need to factor out a 25 from this group. I don't need to factor anything out from this group because his leading coefficient is already 1. So factoring out 25, x squared plus 8x plus y squared minus 2y equals negative 376. Now we're going to do the completing the square portion. So we'll be taking this number 8, dividing it in half, and squaring it. So 8 divided by 2 is 4. 4 squared is 16. So we will be adding 16 here. And remember, that's going to need to go on this side as well, and we'll have to multiply it by that 25. On this side, y squared minus 2y, we're taking this negative 2, dividing it in half, and squaring it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we are adding 1 here. So here we have our negative 376, and we are multiplying 25 and 16 and adding it over here. So 25 times 16. And then here, there's nothing out front, so we're just going to add a 1. So they have to be added on both sides. We added it here, and here, here, and here. So let's simplify. 25x squared plus 8x plus 16 plus y squared minus 2y plus 1 is equal to, hold on just a sec, had to pull out my calculator there, is equal to 25. Now I can factor each of these. So 25, this will be x plus 4 quantity squared plus y minus 1 quantity squared equal to 25. I want to make this number over here into a 1, so I will divide everything by 25. Conveniently, they just cancel out over here, and I get x plus 4 quantity squared plus y minus 1 quantity squared over 25 is equal to 1. Now, if it helps to write a 1 underneath here, you certainly can, because we do need to graph this ellipse now. So the important things, we're going to need to plot the center, we're going to need to plot the vertices and the co-vertices. So the center we can grab straight from here. The center is at -4, +1. That'll be right there. This is my center. Once again, the y-axis is the major axis, which has happened in way too many of these problems, but I'll fix that later. So the bigger number is underneath the y, which means that this is a squared. A squared is 25, a is equal to 5, and the y-axis is the major axis. Here we know b squared is 1, so b is equal to 1. So for plotting our vertices, they should be 5 units away from the center. Because y is the major axis, they're going to be up and down from the center. So this is one of my vertices. Here's the other one of my vertices. To plot the co-vertices, those are going to be b units away from the center and on the minor axis, which is the x-axis. So 1 unit away, this is a co-vertice, a co-vertex rather, that's another co-vertex. And, oh, that's, I've drawn worse ellipses. There it is, that's the ellipse. So a lot of these problems ended up having the y-axis as in fact, all but one had the y-axis as the major axis. But the same process works with the x-axis being the major axis. It's just the vertices would be to the left and right of the center as opposed to up and down. So anyways, I think that these are a lot of fun. I hope you have fun doing these. I hope you have a good time remembering how to complete the square. And I will see you in the next video, which will be the last video of the class. All right, bye.